one, we're going to find the radius of convergence and interval of convergence for this series given. All right, so let's write this as, we're going to use the ratio test and set the limit less than 1. And you get the limit of, as n approaches infinity, of absolute value of a sub n plus 1 divided by a sub n. So that's your ratio test, and this is your a sub n. So filling everything out, we're going to get the limit as n approaches infinity of absolute value of n plus 1. And then we're going to have the absolute value of x minus a to the power of n plus 1 divided by b to the power of n plus 1. All right. Times, and then we can take b sub n. All we're going to do is we're dividing by a sub n, and we're just flipping this around. So it's going to be b sub n divided by n times absolute value of x minus a to the nth power. Since I put the absolute value in there, we don't need it there, because all we need the absolute value sign is on this piece. All right, so let's straighten this all up. This is going to give me the limit as n approaches infinity, and we're going to have this piece here, n plus 1 divided by n. So simplifying that, if I divide each piece by n, I'm going to get 1 plus 1 divided by n. All right. Now, for this part, I have b sub n divided by b. So this is going to be b in the denominator. So this is going to be times b, and we're going to have absolute value of x minus a. And that's because when you simplify these two using your quotient property, you're just going to get 1 because the n's will cancel. All right, so when you take the limit of this, we're going to get this equals, the limit of this is just 1. So this is going to equal x minus absolute value of x minus a divided by b. Now, by the ratio test, the series converges when it's less than 1. So if this is our limit, it has to be less than 1. So r equals b if and only if we have x minus a is less than or is greater than negative b, because we can write this real quick as absolute value of x minus a is less than b. So I'm going to cross multiply there. So now I can write this like this. Now add a to both sides to solve for x, and you're going to get a minus b is less than x is less than a plus b. So there we have our interval or our radius of convergence. Now to find the interval of convergence, we have to test our endpoints. This one and this one. These are called the endpoints. So let's do that, and let's see what we get. So when we have x minus a equals b, the limit as n approaches infinity of our function, a sub n, or our series, this is going to be the limit as n approaches n, which equals infinity. So our series diverges. Therefore, our interval of convergence is, since this is divergent, is you have to have open intervals. So it's going to be a minus b, and our other endpoint is a plus b. Thank you. Have a nice day.